So our next paper is by Fama and French, Luck versus Skill in the Cross-Section of Mutual Fund Returns, the classic question. And what's interesting here is they took a completely different approach to that classic question. So far, we've been looking for skill by guessing some characteristic that could let us see the good funds going forward. Our puzzle was maybe the average fund isn't very good, but surely there's some good ones out there and some bad ones out there. So we had to guess how could we find the good ones and then find a portfolio of good ones going forward. Well, one might say, look, a fund manager might say, there's lots of good funds. Our fund is good. You just didn't find a clever enough device to find that portfolio. 1 year returns, that's really noisy. 5 year returns are really noisy. If you had just looked at our fund, you would have known how good we are. What's brilliant about Fama and French is they attack this question, are there good funds versus bad funds, without having to be clever about how to find the good funds at all. The good side of this is you don't have to be clever. The bad side of it is we can detect whether there are good funds without finding out which ones the good funds are. So that's useful for academics and not so good if what you want to do is invest and find the good funds. So let's read Fama and French, Luck versus Skill in the Cross-Section of Returns. They start with a very important point, the point of equilibrium accounting. Active investment must be a zero-sum game. Everybody forgets this, and it's very important to remember. The average investor must hold the market portfolio. That's just an identity. Doing anything other than the market portfolio is a zero-sum game. The average alpha relative to the market portfolio is zero. For anybody to get a positive alpha, somebody else must get a negative alpha. And there's a big puzzle there. Who agrees to be the loser? Anybody can avoid being the negative alpha fund by simply indexing. Now, if we live in a multi-factor world, you might choose to have negative CAPM alpha because you want exposure to some other factor. But in the skill dimension, there's no reason anybody should be there and be an active trader who is losing. And for any active trader who wins, there must be an active trader who loses. That's a deep point, and it permeates Fama and French's analysis. But let's go look at what they actually did. So Fama and French run a simulation. They ask the question, suppose all funds truly have zero alpha. Now, surely due to luck, we'll see some good ones and some bad ones. If all funds have zero true alpha, how many should we see with positive alpha and negative alpha? Let's just tabulate the distribution of alpha. Now, they're more clever than this. They look at the distribution of the alpha T statistic. They run a regression of returns on the market and other factors. This is 4-factor alpha they're looking at, a 3-factor alpha. As you know, the standard deviation of the estimated alpha is standard deviation of the error over square root of t. So they tabulate the distribution of the alpha t statistic, alpha divided by its standard error. What that does is it removes the influence of funds who last a very short time and therefore are more likely to be lucky, or funds that take on a lot of idiosyncratic risk and are more likely to be lucky. By tabulating t statistics, we put them on an even footing. So here's the question. What should be the distribution of t statistics if there is no true alpha at all? If there's no alpha at all, you might say, well, I know my t statistic distribution. 5% of the funds should still have an alpha t statistic greater than 1.64 and 2.5% greater than 1.96. If there is some skill out there, we'll see more good funds than there should be just due to chance. Now, they didn't quite do that because, of course, what if the errors are correlated across the funds? What if the errors aren't normal, and so on and so forth? And that's why what Fama and French do is a very careful and elaborate bootstrap simulation. The result isn't, in the end, that different from just looking at t statistics. Here's their idea in graphical form. We'll find the distribution. Suppose all the true alphas are, in fact, zero. We'll find the distribution of alpha t statistics due to just luck. Then I put that the simulated distribution in blue. Let's compare that to the actual distribution of alpha t statistics. If the actual world was generated by a distribution of true alpha that I've put in there in green, then we'll add that luck and the distribution of actual alpha t statistics will be red. It'll be wider. And in fact, they don't do this, but you can. We can invert and find from the simulation and from the true distribution what is the underlying distribution of true alpha. Now that won't tell us who has the true alpha, but we'll be able to tell how many good funds are there really, how many bad funds are there really. We'll be able to see if there is skill without being clever about finding who has it. And that was a brilliant idea that they had. So let's go look at the results. What are we going to do again? We're going to simulate how many alpha t statistics will we see if there is no true alpha, and then see how the world's distribution of alpha t statistics looks like. So here's their tables. And how do you read this table? Let's start with a number. Let's start with 95 and 1.68, this number here. That says 5% of the funds should have a t-statistic greater than 1.68 if there were no skill at all. This is the simulation column. That's about the t-statistic distribution. So what does it look like in the world? Well, I don't have exactly 1.68, but it's in between there. You can see something like 4.5% of funds in reality have a t-statistic greater than 1.68. So there should be 5%, just due to luck. We should see 5% with a t-stat greater than 1.68. In the world, we only see 4.5. There aren't enough funds. There aren't as many funds with positive t-stats as would just be due to chance. Pretty depressing on the upper tail. Things look even more depressing on the lower tail. 5% of the funds should have a t-statistic less than negative 1.71. In fact, we don't have a 1.71, but we have a 1.74, which is pretty close. About 20% of the funds have a t-statistic less than minus 1.74, and the median fund has a t-statistic of minus 0.62. So the median fund underperforms the market. There are more bad funds than there should be just due to chance if funds had zero alpha, and there aren't enough funds doing better there aren't as many funds doing better than 1.68 as there should be. Pretty depressing. Now, this is three-factor returns net to investors. How does that look? For example, this is $5 million. They cut it many ways. Among funds with $1 billion or more assets under management, maybe the big funds look better? No. The big funds look even worse. There should be 5% of funds with a t-stat greater than 1.64. In fact, eyeballing in between here, there's about 3.5% of the funds have a t-stat greater than 1.64. 5% of the funds should have a t-stat less than 1.67. In fact, something like 30% of the funds have a t-stat less than minus 1.67. So returns to investors is pretty depressing for big funds as well as small funds under three-factor net returns. I made a graphical version of the same thing. This is exactly that table. Done in graphical version. The the thin blue lines are straight off the table from Fama and French. The thick blue lines, I smoothed the histogram. So this is their simulated distribution. Around 0, it shows you how many funds there should be with positive and negative t-stats. The red line is how many funds there are with positive and negative t-stats. And you can see the depressing picture. The average is shifted to the left. The average alpha is negative. It shouldn't be that case. And we were hoping to see the red line above the blue line, more good funds than just due to chance. In fact, there are even less good funds than just due to chance. Other ways of doing it, these were the three-factor net returns. Fama and French do this a lot of other ways. How about four-factor returns? Again, net of fees to investors. Does it look any better? No. It still looks just as bad. 1.72, 5% should have a t-stat greater than 1.72. We're still looking at numbers like 3.5%. Same among the big funds. 5% should have a t-stat greater than 1.67. In fact, it looks like about 2.5% have a t-stat greater than 1.67. Now that's net of fees. Maybe there is some skill before fees, and it's just getting soaked up in the fees. We would see that in the gross returns. So gross returns means before taking out fees. Here things look a little bit better. The median fund has a 0 alpha, so that negative performance was just fees. Let's look at the 5% percentile, 1.72. In fact, hallelujah, there should be 5% with a t-stat more than 1.72. It looks like about 5.5% have a t-stat greater than 1.72. And if you look out in the absolute tail, 1% should have a t-stat greater than 2.52. It looks like about 2% have a t-stat greater than 2.52. So there's a little bit of skilled funds in gross returns before investors way out on the right-hand tail. The left-hand tails are still as depressing as before. Big funds, the same story, 2.36, 2.30. There should be about 1% that good. There's really about 2% that good. So Fama and French do find a very small number of funds that actually have skill. Of course, one could always say this is another factor rather than more skill. Something very interesting is happening back in the end of the paper. This is table A1 in the appendix, capital asset pricing model. Here is where Fama and French only risk adjust using the market, not their 3 factors, not the 4 factors. This is the traditional alpha. And these are net returns after fees. So this is what investors get. And notice here, we actually see some skill, or at least some outperformance. 1.61 here means that 5% of the funds should have a t-stat greater than 1.61 if there were no skill. In fact, look, about 6% of the funds have that skill. And this is skill that gets returned to the investors. The median fund still isn't so great, but there is a much bigger sign of skill relative to the CAPM. Same thing on the big funds. These are the $5 million. These are the $1 billion funds. 5% of the funds should have a t-stat greater than 1.56. It's somewhere in here. It's about 6% of the funds have a t-stat greater than 1.56. So you see, at least at the right end, here is a sign of skill that actually is returned to the investors relative to the CAPM. Of course, Fama and French would say, quite rightly, how do they get this skill? These are the value funds. They're delivering positive CAPM alpha by being in value. And that leads to the question that I asked before. Well, how much of the outperformance that we even saw before was exposure to still unknown factors? How much is skill and how much is just exposure to multiple factors now that we know about how many multiple factors there are? We'll leave that question for the future. But nonetheless, the technique is the interesting one, worth emphasizing. Fama and French were able to tabulate how many funds should there be with skill, assuming there is no skill. By looking at how many we actually see, we can determine how much skill or alpha, whatever you want to call it, is there out there without us having to be clever about finding the funds that actually are skilled. Very interesting calculation.